Word arrangement. The rule for arranging a word with repeated letters treated as the same and letters used only once. This is an example of a word with repeated letters that are going to be treated as the same. And what is the meaning of treating them as the same? Or what it means is we have the letter L is repeating, the letter E is repeating. When we treat them the same, we are supposed to take into consideration when we arrange the letters of the word cell phone. Now, let us recall the fundamental counting principle, which simply states that if there are m ways to do one thing and n ways to do the other thing, then there are m times n ways to do both things. This fundamental counting principle is very important because you notice that at any point where we are arranging letters of a given word, we'll be using this concept to come up with the exact arrangement. Now, let us look at the rule for arranging words with repeated letters treated as the same and letters used once. And the rule simply states that the number of different ways that n letters can be arranged where m1 of the letters are identical, m2 of the letters are identical, m3 of the letters are identical, and so on up to mn of the letters are identical, is given by n factorial over m1 factorial times m2 factorial and so on up to mn factorial. What we need to understand in this rule is when we say n factorial, we are referring to the number of ways we can arrange a word with any different letters, So the rule for that is simply n factorial. Then when it comes to the bottom, the m1 factorial and so on, we are simply saying here are m number of letters that are repeating. But when we consider them to be different, then the number of ways we can arrange them is m1 factorial. The same can be said to the rest. But what is important is to know that we'll be having letters and you can count how many there are repeating. But when you try now to arrange them, you consider them as being different. Therefore, the arrangement of a number of letters that are different is simply the number factorial. That is all what it means. You understand it more as we try to give some examples in relation to this. Let us look at this example number 1. How many ways can you arrange the letters in the word cell phone? Repeated letters are treated the same and letters are used once. Right. The word treated the same is what should call our attention to say, what is the meaning of this? It means we have to consider the L's that are repeating, the E's that are repeating, and then from there, the formula that we are supposed to apply is this one, because that's the rule for arranging letters of a word with repeated letters. So a solution, we first then identify the number of letters that are repeated. To start with, let us look at the 2 L's which can be arranged in 2 factorial ways. So we are saying, yeah, the 2 L's, but when we arrange them, it's like we are considering them as they are different. So we'll be having 2 different letters. And how does that go? Here are the 2 positions that they are supposed to fill. How are they supposed to fill them? The first position, any of the 2 L's can occupy. This is why there is 2. Then once this position is filled, the remaining L will occupy here. So now using the fundamental counting principle, we are simply saying 2 times 1 will be the number of ways we can arrange them together. This is why we have said the 2 L's can be arranged in 2 factorial ways. It's because of this understanding, right? Then we go to the 2 E's that are given, right? They are repeating there, so they can also be arranged in 2 factorial ways. The way I've explained here is the way you should also do here, right? Therefore, once we have checked all the repeating letters, as we can see, we no longer have any. But then we need to know how many letters are there in the word cell phone, because we shall need the n factorial, which gives us the number of letters in the word, which we are going to consider as different, right? So there are 9 letters. At the end, the word cell phone can be arranged as 9 factorial over the repeating L's, which is represented by 2 factorial, and the repeating E's, which is 2 factorial. So the repeating L's, we can only arrange them in 2 ways. There is in 2 ways. So that is the value that will occupy the denominator. The 9, like I've said, representing the n, the number of letters, but for us, it will be, they are all 9 different letters. So there's a rule to arrange different letters in a word. You simply take the number of the letters in the word, then factorial, which is what we did here. So as such, we are through with the arrangement of the letters of the word cell phone. Okay, let us now look at example number 2. How many ways can you arrange the letters in the word accommodation? Repeated letters are treated the same and letters are used once. Right, the solution to this would be, since we are aware that we want to use this formula, and besides the fact that it is said that the repeated letters are treated the same, that means we have to take into consideration the repeating letters. So in this case, we have the A is repeating, the C is repeating, the O is repeating, the M is repeating. I think I've said all those letters that are repeating. So as such, we pick on the first. Let us just check on the number of A's. There are 2. So 2 A's can be arranged in 2 factorial ways, right? Then we go to the next. 2 C's. They can also be arranged in 2 factorial ways. Then we go to 3 O's, which can be arranged in 3 factorial ways. I also want at this point to repeat what I have said in terms of when we have the 3 O's that are repeating, we are simply saying they are going to occupy 3 positions because there are 3 O's when we arrange the word accommodation. But to arrange those 3 O's, we consider them as they are 3 different letters, right? So that at the end, the 3 positions that the 3 O's are going to occupy are the ones I've indicated, the 3 columns. But we are saying the first position, n of the 3 can occupy the first position. Once we fill this position, we are left with 2 O's. Then position number 2, n of the 2 can occupy there. Once we fill this position, we are only left with 1 O. So the last position can only be filled by 1 O, right? Then we go on to check, we have 2 M's, which can be arranged in 2 factorial ways. So in the same manner, this is all what it takes. But then when we say 3 factorial, it's because we are applying the fundamental counting principle, which allows us to say, if this position can be filled in 3 choices, the second 2 choices, the last one, 1 choice. What about together? Then this is when you say 3 times 2 times 1, which gives us 3 factorial. So having done this, now we are done. We need to understand or count how many letters do we have in the word accommodation, right? And if we count them, there are 13 letters, right? The 13 letters, we are going to consider them different so that we find our n factorial, right? So at the end, we are simply saying the word accommodation can be arranged in 13 factorial, 13 the number of letters we have in the word accommodation, over the 2 A's represented by 2 factorial, the 2 C's by 2 factorial, the 3 O's by 3 factorial, the M by 2 factorial. And I'm saying, understand, this will be the arrangement of the letters that are repeating. But as we arrange them, we are considering them as if they are different. But otherwise, you would see that it's simply concise to say, once we know that we have 2 A's, we know that it will be 2 factorial. But I want you to understand the idea behind it. Why are we simply saying 2 factorial? What is happening? So as I explained here, this is what is important to understand, so that at the same, when you are using the formula, you simply make sure that the number representing the repetition of a particular letter is that number factorial. Then you plug them into the formula.